Hello guys, this is Lungzels here, and today we'll be continuing Neon. Now with that out of the way, let's get into it. Other uses for neon. People have found a number of other uses for neon over the years. In the 1930s, for instance, airports marked their runways with neon lights because reddish-orange glow shone through fog and haze better than other colors. Today, most runaways are marked with krypton-filled lights, which emit very bright blue-white flashes. At the heart of the Geiger counter, a device used to detect radiation is a Geiger-Muller tube. This is a tube filled with an inert gas, typically neon or argon, and in some cases an organic vapor. A metal or metal-coated outer wall serves as a negatively charged electrolyte. The cathode. A wire passing up the center of the tube serves as a positively charged electrolyte, the anode. When radiation passes through the tube, it ionizes some of the gas molecules. Positively charged ions are drawn toward the cathode, and negatively charged ions are drawn toward the anode. As the ions rush one way and the electrons the other, they ionize additional gas atoms along the way. The result is a short, sharp surge of electrical current that typically is used to generate a click. The more clicks the Geiger counter emits, the higher the level of radiation. Neon-filled tubes are used as electric switches. Under normal circumstances, a neon-filled tube acts as an insulator, so no current flows through it. But when there's a surge of voltage, the neon tube fires. The gas inside is ionized. The tubes light up and electricity is able to pass through it. In a voltage regulator, this characteristic of neon is used to bleed away excess voltage before it could damage anything. In specialized tubes like boron, this is used to instantly switch current to a different electric circuit as required. This kind of neon tube switch is much faster than a mechanical switch would be. Geiger counters like this one are used to detect radiation, which are typically indicated with a loud click. The more clicks, the higher radiation count. At their heart is a tube filled with inert gas, such as neon. Liquid neon is used as a cryogenic refrigerant. The word cryogenics means of both the study and production of extremely low temperatures. Generally, temperatures that are below negative 238 degrees Fahrenheit and negative 150 degrees Celsius. Liquid neon has a lower boiling point than any gases except helium and hydrogen. And although it's not quite as cold as they are, its greater density means it has 3 times the refrigerating capacity of liquid hydrogen, by volume, and more than 40 times the refrigerating capacity of liquid helium. Scientists at the Yale University in New Haven, Connecticut, are currently studying the use of liquid neon as a detection medium for neutrinos. These mysterious particles carry no electrical charge and have very little mass, which means they pass through ordinary matter as if they weren't there. They're produced by the sun and other stars, and trillions of them zip harmlessly through your body every second. The Earth itself is pretty much transparent to neutrinos. Clean. clean, cryogenic, low-energy asteroids with noble gases is a project. Still very much in the early experimental stage. I fill a large vat with liquid neon and watch for the very rare flashes of ultraviolet light produced when a neutrino interacts with an electron or a nucleus of a neon atom. Studying these flashes can tell us more about neutrinos, specifically how much mass they have and how much energy they carry as they hurtle away from the sun. Learning more about neutrinos may teach us more about how stars, such as our own sun, work, may even provide us clues to the ultimate fate of the universe. It would be appropriate if neon, produced in the furnaces of stars, and the fourth most common element in the universe, were to help us solve the deepest mysteries of the universe. That would be a pretty impressive achievement for an inert gas. Most people think in the good terms of red, orange sign reading goodies. And that is for today's book and the video. Hope you guys enjoyed, and I'll see you guys again very, very soon. Later. Hello guys, it's Angelus here, and today we'll be reading Boron by Rick Adar. Introduction. Francis Maron Smith, dubbed Borax Smith and the Borax King, was a Winston's farm boy who went west in 1867. He had just turned 21 and wanted to make a fortune in gold or silver. He made it instead of borax, a boron compound. His wealth did not happen overnight. However, he wandered for 5 years across the territories west of the Rocky Mountains, prospecting when he could and working odd jobs when he had to. Smith's big break came in 1872. He was cutting wood at Columbus Marsh, Nevada, for a San Francisco-based borax company. The marsh was in the middle of nowhere, about halfway between Las Vegas and Reno. The job was to fill the boilers for the vats and that refined Ulex ore, a source of boron and oxygen compounds called borates. The ore, called cotton wool for its fluffy white appearance, was collected from the surface using rakes and was brought to the vats. Curious about the bright whiteness of Teal's Marsh, 15 miles, 24 kilometers to the northwest, Smith found a much richer cotton wool field. Until then, the marsh has served the source of sodium chloride, or common table salt, used mostly for refining gold, AU, and silver, AG, from the Nevada mines. Smith staked a claim and set up a borax refinery at the edge of the marsh with his brother. Their find was so prolific and high grade that the first year of operation, they doubled up. Boron is a soft, non-metallic element that has both crystalline and anomalous uncrystallized forms. The black brittle solid shown here is boron's most common crystalline form. They doubled the country's output of refined borax. Within 5 years, his company was using mule teams to haul 30-ton, 27 metric ton loads of refined borax, 160 miles, 258 kilometers north to Wadsworth, Nevada. There, the borax was loaded onto the recently completed Transcontinental Railroad for distribution in San Francisco, California. Until Smith's find, borax had been costly and used as a chromatic glaze or flux, a substance used to help metals or minerals fuse together. For working precious metals, Thiele's Mars made borax a common household product. Smith then set out to expand his holdings. He brought out his brother in Nevada 6 years later, in 1890. He acquired borax in operations in Death Valley, California from William Tell Coleman and combined them with his own to form the Pacific Coast Borax Company. The company established its familiar 20 mule team trademark in 1991. Inspired by mule teams, Coleman's company used to transport borax out of Death Valley. By 1900, Smith was very wealthy. In the turbulent economic years that followed, he lost his fortune, made another, and lost that as well. But the company this farm boy launched in the Nevada desert rose to become an economic powerhouse that today continues to mine borax and produce boron compounds such as a subsidiary of the British mining conglomerate Rio Tinto. After huge deposits of boron compounds were discovered in Nevada and California in the late 19th century, the once rare substances became common enough to be used as laundry and cleaning products. Chapter 1. What is boron? Elemental boron B is a light element with several forms that differ in the way that the atoms are packed. Non-occurring in nature, the element is most familiar in compounds to make fiberglass, heat-resistant borosilicate glass, and cleaning products. However, its most important role on Earth is an essential micronutrient for plants. The element is a rare portion of Earth's crust, representing only about 17 atoms out of every million, although it is about 57,000 times more common in rocks than gold. Boron is found in more than 200 minerals, but only 12 are commercially significant, and only 4 satisfy nearly 90% of the boron demand. Besides glassware and cleaning products, boron compounds have been used in semiconductors, fire retardants, cancer treatment, and high-energy fuel, cosmetics, adhesives, pesticides, wood preserves, and the leather tanning industry. Boron is also an essential part of silly putty. Other boron compounds are used as phrases in pyrotechnic flares, fiber optics, and advanced aerospace structures. The discovery of boron. Elemental boron was isolated in impure form in 1808 by French chemists Joseph Gay Lusset and Lucius Jacques Benard, and independently by English chemist Humphrey Davy. They all isolated boron by combining boric acid H3BO3 with potassium K. Gay Lussac and Benard called it bore, which is still its name in the French language. Davy, thinking a new substance that had metallic properties, pursued the name boracium, which combined borac, the older form of boric, with Latin ending that indicates a metallic substance. However, after chemists determined it was not a metal, a new element was called boron. In 1812, the name partially combines borax and carbon, element 6 in the periodic table. Although boron is relatively recent discovery, boron compounds have likely been known for a few thousand years. Probably first, though, the common borax, which can still be bought in many grocery stores for a relatively small price. Until 1865, when vast deposits in Turkey and California were discovered, borax was costly and hard to find. Early borax deposits were found in dry lake beds in Tibet, where it was known as tin cow from its sarcastic name. It was transported in bags tied to sheep that were driven over the Himalayas in India. Many civilizations have an old term for borax, Nishna borak in Greek, borath in Hebrew, barak in Arabic, borak in Persian, and burak in Turkish. However, all seem to be translations of the Arabic word meaning to glitter or shine, and there's no way to verify it if they all refer to the same substance. And that is for today's video. Hope you guys enjoyed, and I'll see you guys again very, very soon. Later.